All right, everybody, welcome to Earth Science. It's time to wrap up marking period 2. So let's talk about what we need. This is going to be all the assignments, although I suppose I do need to add in one more lab, and then I'm going to talk about what we're going to do for one more test here. That's what this video is going to be about. Please watch this whole video. There's going to be some important pointers within it, okay? So we made it through, these are all jumbled up. These are sorted by dates. We made it through 7 classworks, so check those. One gets dropped, so one low grade doesn't matter. Look for the other 6. Um, then labs, we had lab 11 and 12 as a double, so that's 1, 2, 3, 4, 5, and then I'll add one more in there that you guys have been working on, the Hawaiian rainfall. So that's 6 labs and 2 tests. So this test, let's talk about it. What I'm going to do, it's going to be just like the last one where the like traditional sense of a test just hasn't been working this year. So the last one we did, I thought went pretty well. And also, as long as you do it and do it well, like I can tell if you just jump in, randomly fill out the multiple choice, and just give me some nonsense for the fill-ins, then that won't be passing. But basically, if you take a stab at it, you're going to pass the test. I didn't do lower than a 65 on the last one, and I won't. I'll do the same thing again, unless you just totally rush job it. It'll have 3 parts. I'm going to have it be exactly like the last one was. So there will be a crossword that I pulled up. It'll look like this, kind of a warm-up crossword just to get you going on some of the ideas that we did. A lot of it's from the reference table, so if this looks like intimidating and holy cow, there's a lot, like air mass, air mass, air mass, air mass, those are all off a reference table. Atmosphere layer, atmosphere layer, atmosphere layer. Those are your atmosphere layers. Pull up the reference tables there, page 14. There's 4 answers. There's your air masses right there on page 13. So there's 4 answers. Um, and you'll get moving on it. Some of it will also be on this sheet right here. With the idea that when air rises, it expands and cools. Remember, if you watch this video, I said your job was to, usually the job is to go ask somebody who took our science already, what happens when air rises? And if they don't tell you expands and cools, I want to know their name, because usually in class we say this like 1,000 times. Now this hasn't been the case this year because of COVID and videos and everything else we're doing. But that idea is pretty critical to how clouds form, because as it expands and cools, it'll eventually cool until it reaches the dew points, which is when we get condensation in clouds and rain and all that jazz. With the opposite happening over here, it compresses and warms and gets warmer and warmer and warmer. So that's a cheat sheet. Have it handy, print it if you have the ability, or just have it open in a tab, and that'll be great. All right, what else might be on that? The second parts of the of what we're going to count for a test. Whoop, I don't know why that happened. All right, it's fixed. The second part of it is going to be just like the other one was. Boy, PDFs aren't happy this morning. Just like the other one was, it's going to be a review book with some questions, and I went through and made a Google form that will probably still be up here. It'll be things like, okay, page 128, question 1. So it's going to have you go through this chapter of the review book on weather and do some questions like page 128, question 1. That's going to be one of them. Okay. Now, some of the things on there, granted, this has been stretched over a while. We've had some COVID breaks. We've had a Christmas holiday. It's gotten a little bit stretched out here. But this is the advantage of using a review book. You can usually find all of the information. I mean, the people that publish this review book put the questions here and put the content here. So it should all be findable if you're patient and you take your time with it. Okay. I think I did 25 questions. Yep. Throughout all of it. Looks like that. And again, if this thing gets turned in and you have a 5, I'm going to say you clearly just went through and click, 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 and turn it in. That's not going to get you a passing grade. Work your way through it. Check out these sections. I'm not going to say first you should go through and try all the questions and read all of this. Some of it we didn't even get to. So you'll see there's chunks I skipped just as a function of this year. Unfortunately, we didn't get to everything. We didn't get to pressure systems. Anyway, do the ones that I said. Check those out. That'll be part 2. And then part 3 is going to be like it was last time, maybe 10-ish questions in a Google Doc where you've got to give me some decent writing answers. It might take you a few minutes to think through some of those, but my timeline on this is basically going to be have it done by Friday. So you got today's Thursday. You got, and I'm saying next Friday. So you have 8 days on all of this, and that's kind of a hard deadline because then the report cards are due. So that's I'm usually pretty easy going with deadlines, but it's more than enough time. I'm thinking this is probably about 2 days worth of classwork, um, and you have 7. So I think you can do it. Um, let's talk a little bit about not this lab, this lab right here. I'm going to include some questions from this lab on that last assessment, but I'm going to give you some hints here because there were I saw some questions consistently coming in wrong, which means that I didn't present that well enough on our way into that lab. So I want to focus it on this graph. I haven't made this last part yet. I'm thinking I'm going to have this graph be right on there though, and you'll have to explain this idea. When if this line represents temperature, so this is like throughout the course of a couple of days, the temperature drops, the temperature rises, the temperature drops, and this black line represents dew point. The big theme on this, one might we have blue skies are basically low humidity versus one where we have snow or high humidity, 100% humidity if we get precipitation. The big difference isn't whether they're going up and down. The big difference is how much is in between them. How far apart are they? So the best answer for when there were blue skies should have been right here at 12 a.m. between the first and the second, because the temperature and the dew point are furthest apart. The further apart they are, the drier it's going to be. And then as they get closer and closer and closer and closer and eventually hit here, it doesn't matter if this is high or low, it's when they're touching. There's likely going to be snow or at least high humidity right there because temperature and dew point are the same. All right, take that back to this cheat sheet that decided to close. Wonderful. There it is. Take that back to this idea. So if you've got a temperature and a dew point here on the coastline, okay, temp up here, dew point down here, you can't have a dew point higher than temperature. That doesn't work. Most people do pretty good on that question. As this comes up and the air rises and the air cools, let's say the dew point stays about the same, but the air is going to cool until it hits the dew point. And that's the moment where all this jazz happens. Like this is pretty much all simultaneous. The air is saturated, the relative humidity is 100%, you get condensation, and condensation is what forms clouds. So it's not about high, low. It's another one of these things in earth science where it's about the difference in between them. The closer those two are, the more humid it is, which is also why the backside of mountains are like drying. They're like they suck things dry. I lived on in the Rockies on the leeward side of a mountain down to the flatlands. So like if you come out of like Kansas, Nebraska, come up, you get to the Front Range. I lived at about I think 9,000 feet, somewhere around there. It was unbelievably dry. I mean, you had to drink water constantly. You know how around here, if you take a shower and your towel's kind of bunched up on the bar, like that's still wet in the morning, it's still damp. That didn't happen there. Like your towels were like boom dry. You could hang clothes and go back out and get them in like half an hour. It would just get sucked dry. Grass didn't grow. Um, it was just a very 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 dry place, and it's because of this that as that air is dropping down the mountain, it's getting warmer. So that means if my dew point's here and my temperature is here, if it gets warmer and warmer and warmer and warmer, those two are getting further apart. And that's what the mathematical idea behind being dry is. That makes it very dry. Okay. Hopefully I said that enough. And then the house thing, I don't know if I'm going to put this on there or not. I haven't decided. The house thing is kind of the same idea. People did mixed results on this, but that if outside, like outside right now, it's been snowing. It's been snowing, all week. So it's reasonably humid outside, even though it's cold. It's reasonably humid. Otherwise, we wouldn't have clouds and snow. But if you take that air and bring it inside and only heat it, you're doing the same thing. You're keeping the dew point the same, but driving the temperature up. which makes a bigger difference between temperature and dew point, which makes it dry, which is why indoors it's so dry in the wintertime. Even if you don't heat with wood, um, that happens. So to counteract that, this little question right here that many people skipped, which is okay. To counteract that, what can you do? People get humidifiers that just dump moisture into the air. People, if you have a stove that has a flat top like this, you could put a kettle on top of it and just keep filling it with water. That water, that water evaporates into the air and increases the humidity in the house. Okay. All right. I wish you luck. Email with any questions, and I'll keep. I got some grades to add to School Tool. I'll keep chucking them as we go, and we'll try to make this marking period end right. If you're one of the gang that has missed quite a bit this marking period, I am willing to negotiate. Hit me up, but you also got to show me that, hey, look at, I'll do this lab, and give me a couple labs. If you got a whole string of zeros, it can be intimidating to say, how am I going to get this all the way back up? Let's contact me. Let's make a deal. Let's get a couple labs done, and we'll see if we can negotiate. It's such a crazy year anyway. We can figure out how to make some deals. All right. To those of you that have been doing all your work, great job. Awesome. And we'll see what goes on in marking period 3. Time to move on to stuff going on Earth, the surface of the Earth, surface processes, and then eventually rocks and minerals. All right. Good luck.